Hello, everyone. So in this section, we are going to talk about trigonometric substitution. When do you use the trigonometric substitution? Like the term of kind of under the square root, if you have the perfect square, like a term a squared plus x squared, or square root of a squared minus x squared, like that. That's the sum of two perfect square under the square root. You cannot get rid of your square root unless if it's just the product of two terms. So that square root and square root cancel out. So that's why it's important to know this substitution. If you see them, you know, like you have to know what type of substitution we are going to use. When you have a squared minus x squared, just substitute a times sin theta for x. It will give you a useful identity, which will become a squared cosine squared and so on. So you can read this part, pause and read and understand, okay? They are from your right triangle, which I posted here. I don't want to make this because the example can take some time to solve. So I don't want to take too much time on reading this part to you. So please pause and read them yourself, okay? So you will understand what is going on all the time. So if you look on the first example that we are about to do is find the integral of dx divided by sines of dx divided by 16 minus x squared to the power of 1, to the power of 3 divided by 2. So if I'm doing this one, because again, as I said, the time. So first thing is the term under the here is what 16 minus x squared, right? So if I look at my 16 minus x squared, this is in which form? Has the form of what? A squared minus x squared. My a is what? 4, where a is 4, right? Because 4 squared is 16. So which substitution are we going to use? We are going to use let x be equal to what? 4 sines of theta. And if x is 4 sines theta, then dx will be what? 4 cosines theta d theta, all right? So again, I'm going to do that substitution here. So that means my integral of dx over 16 minus x squared to the power of 3 over 2 would be written as the integral of 4 cosines theta d theta divided by 16 minus x is what? 4 sines theta square to the power of 3 over 2, right? If you look at this one, this is exactly the same thing as 4 cosines theta d theta, parenthesis 16 minus 16 sine square theta to the power of 3 over 2, right? By factoring 16 under the denominator, we will get what? Again, pause the video if you think I'm going too fast to read. So I will have 4 divided 4 over 4 times cosine theta d theta. If I factor 16, let me use bracket here, 16 times 1 minus sine square theta, right? And 1 minus sine square theta is what? Cosine square theta. Good. That's an identity, right? So I will get 4 divided by 4 cosine squared theta, and we have a cosine theta d theta on the numerator, to the power of what? 3 over 2. I mean 16, not 4, 16. So now, the power 3 divided by 2 is just like q square root, right? So 16 is what? 4 square, right? So 16, this one will give me exactly 4 cosine theta divided by 4 to the power of 3, which is what? What is 4 to the power of 3? That's 64, right? Cosine to the power of 3 theta, and then d theta. So by simplifying this one, if we simplify, we will get 1 over 64, right? I mean, 4 divided by 64 is 1 over 16. So let me simplify that. 1 over 16 integral of cosine theta and cosine square cube theta would be 1 divided by cosine square theta d theta. But what is 1 over cosine square theta? Which identity is that? Secant square theta. So basically, I will have 1 over 16, the integral of secant square theta d theta. And what is the antiderivative of secant square theta? That will be 1 over 16 tangent theta plus c, right? So I'm not done yet. So then now you remember we said, what did we said? We said x is equal to 4 sine theta, right? So that means sine theta will be equal to what? X divided by 4. So by writing my right triangle, because I have to write back in terms of x. So if this is theta, theta is what? Opposite divided by hypotenuse. So in that case, adjacent will become square root of 16 minus x squared, right? So we have tangent theta. In this case, my tangent theta will be opposite divided by adjacent, so which will be x divided by square root of 16 minus x squared. So I will substitute back. So my final answer will be 1 over 16 times x divided by square root of 16 minus x squared plus c. And that's it. That will be my final answer. Next, we are asked to evaluate this integral. We will do exactly the same thing again. So first thing will be what? I'm not going to do the fourth one, okay? We'll stop at 3. Because this example take too much time, and I don't want a long video. So again, first thing we are asked to integrate the coefficient of x squared has to be 1 all the time. So I'm going to take the 4 out. If I factor 4, so you can see this one will become 1 over 4 plus x squared, right? Dx, and we can take the 4 out. So basically I will have 2, it will be 2 integral of 1/2 square plus x squared, right? Because 1 divided by 4 is 1/2 square. So in this case, my a is what? 1/2. So the integrand is in which form? Is in the form a squared plus x squared, right? With a is equal to what? 1/2. So for that being said, which substitution are we going to use? Is in form of a squared plus x squared. So we'll be using what? X is equal to 1/2 tangent theta. So which mean dx would be what? 1/2 secant squared theta d theta. So let's replace this one quick. I'm not going to use the limit of integration until the end, okay? So now I will just set my 2 times integral of square root of 1/2 square plus x square dx. Okay, we will leave the limit of integration until the end. So I'm gonna make it indefinite integral so far. So will be 2 1/2 square plus x is what? 1/2 tangent theta square times dx is what? 1/2 secant square theta d theta. That's my dx, right? So this 1/2 and this 2 will cancel out, so it will be 1. And if you look inside this square root, I can factor what? 1/2 square, right? Because 1/2 square is 1 over 4. And then it will left what? 1 plus tangent square theta. And then times, we already simplified this 1/2 and this one. So secant square theta d theta, right? So if you look, 1 over 4 can go out. And what is 1 plus tangent square? 1 plus tangent square is what? Secant square, right? This is just like secant square theta. So again, this 1 over 4 will be 1/2. So we'll have square root of secant square theta times secant square theta d theta. Square root and square would cancel out. So we'll have secant theta times secant square theta, which will give me that will give me 1/2 integral of secant to the power of 3 theta d theta. So in this case now, I will be using what? The reducing formula, right? The reducing formula of secant. We have already done that, so please, I'm going to pause the video and put the answer. Just use that. If you remember secant, the integral of secant to the power of m theta d theta. So you use that to integrate this one, okay? By doing so, you will get 1 over 4 secant theta times tangent theta plus ln of absolute value of secant theta plus tangent theta, close the parenthesis, plus c. That's what you will get. But again, you know, we have integration, the limit of integration, that was in terms of x. So I have to rewrite each of these one in terms of x. By doing so, what will I get? Look, we haven't done yet. We know since the beginning, the substitution that we use is what? We said x is equal to 1/2 tangent x, right? So this means tangent theta. So this means tangent theta will be equal to 2x, right? So I'm going to draw my right triangle again. This is just to show you, and you will always do this one. If this is theta, we know tangent is what? Opposite divided by adjacent. And then in this case, my hypotenuse will be 1 square, which is 1, plus 2x square, which is 4x square. On this one, we already have tangent theta. We know tangent theta is what? 2x. Tangent theta is what? 2x. So we were looking for secant theta. We know secant theta will be, secant theta is what? Secant theta is hypotenuse divided by adjacent. So which means my secant theta will just be square root of 1 plus 4x squared, right? So that means this one will be what? Square root of 1 plus 4x squared. And this one also will be square root of 1 plus 4x squared. So let's substitute back, and then you will see what I was trying to say is, since the beginning, our 2 integral from 0 to 2 square root of 1/2 square plus x square dx will be equal to, now 1 over 4, going to use a bracket, 1 over 4 secant theta is what? Square root of 1 plus 4x squared times tangent theta, which is 2x, right? So if I want, I could put 2x in front, and then plus ln absolute value of secant theta. Secant theta is square root of 1 plus 4x squared plus tangent theta, which is 2x, absolute value. Now close the parenthesis and the bracket. We have what? The limit of integration is from 0 to 2. So I'm going to first substitute 2. If I substitute 2, I will get 1 over 4, right? Parenthesis, if I substitute 2 for x, 2 times 2x is 4. So I will have 4 inside the integral. We will have 2 squared, which is 4. 4 times 4 is 16. 16 plus 1 is 17, right? Plus ln of absolute value of square root of 17 plus 4. And then we will substitute 0. And you can see if I substitute 0, 2 times 0 is 0, and 0 times anything will become 0. This will be 0. And if I substitute 0 inside the absolute value, 2 times 0 is 0. 4 times 0 is 0. 0 plus 1 is 1. Square root of 1 is 1. And ln of 1 is 0 as well. So minus 0. Right? So which means my final answer will be 1/4 for square root of 17 plus ln of absolute value of square root of 17 plus 4. And that's it. You can type this in your calculator to get the approximate value. The approximate value, which will be 4.65. Okay. So let's move to the last one. So the last one is finding the integral from 1 to 4 square root of x squared plus 4 x minus 5 divided by x plus 2. So, the goal will be, first thing, we have to write this one as a perfect square. It can be either the difference of two perfect square or the sum of two perfect squares. So we know we have x squared plus 4x minus 5, right? What do we need to add to make this one a perfect square? We have done this in college algebra. So it's plus 4, right? Because you divide the coefficient of x by 2 and square that. So 4 divided by 2 is 2, 2 squared is. But if I add 4, I must subtract 4 as well. So my x squared plus 4x minus 5 will be the same thing as x plus 2 squared. Negative 5 minus 4 is negative 9. Right? So this is the same thing. So that is why if I'm asked to find the integral of and from 1 to 4 square root of x squared plus 4x minus 5 divided by x plus 2 dx, I can say it's the same thing as finding the integral from 1 to 4 square root of x plus 2 squared minus 9 divided by x plus 2 dx, right? So you can see I can use a u substitution now, because this is what is under the parentheses, and that's the same thing I have on the denominator. So let's say let u be equal to x plus 2. Then of course we know du will be dx, but the integration, the limit of integration also will be changed, because if x is equal to 1, then u will be what? 3. And if x is equal to 4, then u will be what? 7, right? 6, not 7, 6. So now my substitution will be what? If I substitute u, I will have from 3 to 7. Why do I like 7? From 3 to 6 square root of u squared minus 9 divided by u du, right? Then I'm not done yet. I cannot still integrate this one because inside the radical now, what term do we have? We have u square minus 9, which is the form of u square minus a square, for which a is, where my a is 3, right? So I have to use my substitution again. I would say let u be equal to 3 secant theta, which means du will be what? 3 secant theta tangent theta d theta, right? And that also will change my integration because the limit of integration will also be changed. You can use your calculator to check that, okay? So now my substitution, after that substitution, I will have my integral from 3 to 6 square root of u square minus 9 divided by u du will be from 0 to pi over 3 square root of u square, which is 3 secant theta square minus 9 divided by 3 secant theta times 3 secant theta tangent theta d theta. So we know secant theta and secant theta would cancel, 3 and 3 would cancel out, right? And if you look inside, we will have from 0 to pi over 3. If I factor 9, I will have 9 secant square theta minus 1. And what is secant square theta minus 1? That is tangent square, right? So this one will give me the integral from 0 to pi over 3 square root of tangent square theta. Of course, let's not forget this one, tangent theta d theta right here, times tangent theta d theta. Then square and square root will cancel out. I can take these 3 out. So I will have 3 integral of from 0 to pi over 3. Tangent theta times tangent theta will be tangent square theta d theta, right? And then the best way here is change your tangent square theta to secant square theta again. So I will have 3 integral from, you can use the power radius from tangent as well, but using the identity make it more easier to integrate because we already know the integral of secant squared theta, right? What is the integral of secant squared theta? That is tangent theta. So I will have 3 parentheses tangent theta. The antiderivative of 1 will be minus theta in this case from 0 to pi over 3. Now we substitute. First thing, you have to substitute pi over 3. So if you substitute pi over 3, we'll have 3 tangent of pi over 3 minus pi over 3. And then you will substitute 0. Tangent of 0 is 0. If you substitute 0 for theta, that also will be 0. So now, so minus 0. Tangent of pi over 3 is what? Square root of 3 minus pi over 3. And that's it. And then if you want, you can distribute your pi over 3. So if you distribute pi over 3, I mean, if you can distribute your 3, so the final answer would be 3 square root of 3 minus pi. And that's it. So I will stop this video right here. You can practice, and I will see you in the next video.